final presentation here with Dave and Mary Jo Nutting from the Alpha Omega Institute, and it's been a wonderful time. We've had them here since Sunday. This will be their, I believe, the 5th time that they've spoken. And the last session we did was dinosaurs in the Bible, and that was a fun one. That one's posted on our YouTube channel if you want to check it out. And my name is Jonathan Bislew. I'm the campus pastor with Maranatha Christian Fellowship, and we're excited to do these presentations on campus because we just don't believe in accidents. We believe that we're fearfully and wonderfully made in the image of God, and that you can trust the biblical account of creation. And Dave and Mary Jo Nutting, they've got a unique story. I mean, Dave's a geologist and his wife's a biologist. So this particular talk is David's favorite because it's geology. Who's the hero of the plot? And so this is his favorite talk, I believe. Well, you're a geologist, right?
My wife's favorite talk that I do.
It's his wife's favorite
I like to do her biology one, actually.
Okay. So, but it's very unique. They were former evolutionists. They actually were totally trained in evolution, and they taught it. And then one day they were challenged in their research and realized 2 plus 2 is not 5, it's 4. And so they, as they put it, they evolved into creationists. And so now for over 40 years, through their ministry, the Alpha Omega Institute, they have been going around doing these creation talks and showing the problems with evolution, as well as looking at what they believe to be solid scientific evidence that supports the biblical account of creation. And so I think this is probably close to 28 years we've been bringing them out here and at the University of Minnesota, just trying to help the young students see an alternative to a naturalistic assumption, to a supernatural assumption of the beginning of the universe. And we believe you can trust the Bible. So with that said, I'm going to just turn it over to Dave here and let him dive into this talk. He's going to speak probably for 59 to 60 minutes in 1 hour. I got to hold him to that. There, he would talk to us for 5 hours if we let him. And then we're going to have a Q&A time. So if you have any questions that you want to ask Dave, and then Mary will join in on that. And if you have any questions, and online, those of you online, if you have questions, just put them there. We can see it, and and they'll do the best they can to answer those questions. So let's give Dave a warm welcome here today.
All right, thank you. You know, for some of you wishing to know what has this all to do with the Bible, after all, this is a ministry that's bringing me in, right? Well, according to the biblical record, you have creation and design, and then wonderful design. But people ask, what happened to that design? If it was so good, why all the death and struggle? Well, you have a thing called the fall, Genesis chapter 3 through 5. And that really got bad for a while, and it went from bad to worse. God said, stand back, better build an ark. It's got to be a great big one, okay? And I'm going to basically clean the slate, in other words. And because wickedness filled the earth for a while. And so there was a flood, and that's what our topic tonight happens to be. Is it real? Or is it good old fiction? And then, of course, after the flood, you have people dispersion all over the world, don't you? And how do you explain that? How do you explain the animals, etc.? So we're going to be doing that as well. Okay. Anyhow, geology. Who is the hero of the plot? Okay, who is the hero of the top? And I think you're going to find out water is, and a lot of it. Okay. So I was at the Colorado School of Mines doing a lecture over there, big engineering, geologic engineering school. And I wasn't even talking about the flood yet. And somebody asked me, you don't believe in Noah and those stinking animals, do you? I said, sure. Don't you? He said, how did Noah get all those animals on board that little tiny boat? Well, it turns out that little tiny boat is not what he pictured that little tiny boat to be. Okay? He looks probably what he saw in the comic books is a little boat like that. And how many species of animals do we have? There's no way they're going to fit, right? But that boat was a lot bigger. It would have been, according to the biblical dimensions of what a cubit is, it would have been 1.5 to 2 football fields in length. Now, is that a big boat or not? Yes, it is. And so when you use that and recognize that ark had 3 decks, there's all kinds of room in that particular boat. So that problem is solved real easily. The flood is one of the most documented events in the Bible, by the way. Okay? And then when you look at the rest of the Old Testament, not just the book of Genesis, you read also about the flood. It shows up all over. Even the New Testament authors accept the flood is genuine. And get this, Jesus himself believed in the flood. Okay? And you can see that in the words that were recorded. But it also is accepted by cultures around the world. There's archaeological evidence in so many different places. And what do you find? You've got Mesopotamia, and there's a flood description right there. And you say it can't be much of a flood description. Well, they have a way of doing it. But then you have a Sumerian king list, names kings who reigned for long periods of time. Then what happened? A great flood came. And after that time, the Sumerian kings couldn't reign that long. Okay? Kings ruled for much shorter periods of time. Do you realize that goes right along with what we see in biblical record? And then in cultures around the world, people were living long ages according to actual historical records that were set down. And then came a flood. Afterwards, lifespans went down, 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 down. So that's a pattern we see. And some people say, well, you can't trust the Bible. People can't live that long, so the Bible has to be wrong. My way of looking at it is this: the biblical record and then cultural records from around the world say they lived longer. What were the conditions like back then that would allow that? That's a different way of viewing it, isn't it? Not trying to judge it by today's standard, but by the standard of the written record. All right, so anyhow, you look at the Babylonian tablets, you've got the same flood, and then you've got the Gilgamesh epic as well, and you've got the 11th tablet of that, and there's an ark. Animals were taken on board that ark, birds sent out during the flood, and the ark landed on a mountain. Afterwards, there was a sacrifice offered. Wait a minute. If anybody familiar with the biblical record of Genesis 6 through 8 will say, that's what they record. Okay? That's what is recorded. And some people say, well, that means that the Bible was borrowed from the Gilgamesh epic. Well, guess what? They think the Gilgamesh epic was the older account, except for one thing. It turns out we have, first of all, flood legends and accounts from around the world, and the biblical record is the most accurate of all of them from the standpoint of precise details. Okay? And we also understand that in the biblical record, it says, these are the generations of, then it gave the name of a patriarch. What does that mean? These are the generations of this patriarch. 6 or 7 times you see that phrase. These are the generations of such and such person. It turns out that that is a way of saying these are the records kept by this particular patriarch. Okay? And now, what do we have? Written records. We have records written down by Noah, too. And That's why you have such specific detail. He was there. He saw it, right? And you've got, let's look at Echoes of Ararat. This is actually a collection of over 300 flood legends from North and South America. What I'm going to say is this: if they're writing these things down, these are the records of, they're writing it down, then those are the oldest documents right there, okay? Now the Gilgamesh epic gets borrowed from that, and other creation accounts from around the world gets borrowed from the original patriarchs doing it. All right, now what do we have here? Discovery of Genesis right here in the Chinese language shows evidence of the reality of the flood and the reality of the first several chapters of the book of Genesis. For instance, the Chinese word for boat is made up of 3 smaller pictures: 8 mouths in a vessel. How do you get that for a boat? 8 mouths in a vessel. Until you start realizing there were 8 people that went through Noah's flood, right? On board that boat called the Ark. Coincidence? Not really. When you look at other Chinese characters as recorded in this particular book right here, and somebody who might deceive you. How about a woman? Smaller pictures. Garden and snake. Coincidental? No. Subject after subject, bunches of words in the Chinese language parallel right with the book of Genesis. And so it's interesting. You can get that book. You can order that for us, from us, or get it from Interlibrary Loan or something like that, okay? But notice the details as given in Noah's, what I call, ship log. He's writing it down as it is occurring, okay? Okay, when is the start of the flood? In the year 1, the 2nd month, day 17. Boy, is that ever specific, right? Some people call the Noah's flood fairy tales. How does a fairy tale normally start? Once upon a time in a far distant land. No. In the 600th year of Noah's life, in the 2nd month, on the 17th day of the month. Exact detail. On the same day, the fountains of the great deep burst open, and the floodgates of the sky were opened. There are 2 sources of water even mentioned here, okay? This is detail. And the detail doesn't start just there. You look at what happened when the ark grounds out on the mountain. That's the 7th month, 17th day. Birds sent out on the 11th month, the 10th day. The earth is dried out. This is in the 2nd year now. And we find out that Noah was told to leave the ark here. That means Noah was on that boat for over a year. You get that? It's a long time in that boat. Is this a local flood or a worldwide one? This sounds like something different than what we see today, right? Usually a local flood comes, boom, it's gone within a couple of weeks, usually. You know, it was not just a little rain. Windows of heaven opened up. The fountains of the great deep burst open. Again, this is catastrophic language here. Something big has happened. It's not a local flood. There are even Bible colleges that somehow say, oh, the flood was a local flood. Why would they say that? That's not what the Bible says, okay? First of all, why would you even need a great big boat the size of 2 football fields up to, perhaps? If it's a local flood, just herd the animals a little ways over there. They'd be better off. Okay, why take birds on the ark if it's a local flood? They'd be better off flying off, right? The water covers the tops of the tallest mountains. What happens if I cover Long's Peak with water in Colorado. What does that do to you guys here? As Bill Cosby used to say, how long can you tread water? The most of the world is covered with water just by covering Long's Peak. And some people say, well, that's a real problem. We don't have enough water to cover the tops of the tallest mountains. Everest is so high. Wow, how do you explain that? Well, look at the top layers of Mount Everest, all the way on down here. You know what those layers are made up of? The type of rock? Rock that's put down under water. And they contain fossils of things which once swam in the ocean. Okay? That is substantiated geology. And now look around here. These are sedimentary layers too, put down by water. And so we say, well, at least this shows you those mountains were underwater at one time. It doesn't prove a flood, by the way. It just shows they were underwater. Standard geologists say, yeah, it took millions of years for pressures in the earth to push those mountains to their present position, right? That's what they'll say. And so if you have any aspirations to climb Mount Everest, guess what? You better do it quickly. Mount Everest is still rising. It's still going up, okay? Not much, but just a little bit. So do it before it gets too high, huh? No, no. So how do you answer that question? We don't have enough water on planet Earth. According to the biblical record, Psalm 104, the mountains rose up, the valleys sank down. The mountains weren't as high before the flood as they are right now, okay? That's the answer right there. So let's just take a giant iron and let's flatten down the earth, make the whole world like a soccer ball. And how much water would we have over the face of the earth? The entire globe. A depth of 1.5 miles deep of water. That's how much water we have right now. And that doesn't even take into consideration what geophysicists are telling us now, that underneath the North American continent, there is a type of mineral right at the boundary of the mantle. And that particular boundary has a mineral called dimwoody, okay? That is a mineral that sweats water. It does. How much water? Doesn't seem like there should be much. Yeah, there is. There's more water in that mineral along that boundary just there under North America. That would amount, if you could bring it all out, it'd make 3 times the amount of water in all the oceans we have in the world today. You see how much water I'm talking about? That is according to geophysicists today. And that was just under North America, okay? Okay, the duration of the flood, wow, over a year. That's not a local flood. That's a global thing. And then God made a big promise never to flood the earth again like that with water, correct? And that was the promise of the rainbow. Since we've had so many local floods, God would not have kept his promise. And he does keep promises, okay? And then we also, let's go from not only just what the Bible says and other cultures said, but there's much geologic evidence. Now, I am a geologist as well, and I also have degrees in mathematics. But when I look around the world, I see much evidence of the flood worldwide. And we're going to look at some of that. Now, one of the things I see are these big rock layers. Underneath the rock layers, if there had millions and millions of years of erosion, this whole canyon should be choked with rocks. Where did all those rocks go? What's going on here? It should be just clogged with rocks. But turns out there's a good explanation for that. And when we look at geologic formations, when we look at erosion, there are a couple different ways of viewing things. One, a lot of water over a little bit of time. The other one, just a little bit of water over millions of years. Okay? Two different ways of viewing it. Both will get the job done, but now which one fits the evidence the best? All right, that's what we need to look at. People ask me, well, what about continental drift? Well, actually, one of the models for the flood is one that's based upon the idea of continental drift, okay? And plate tectonics. And what happens is we do realize that it seems like the oceanic crust is diving underneath continental crust, okay? Coming down like that. It's called subduction underneath. And what happens at that subduction zone, you frequently will see volcanic activities over here, right? Frequently, the ring of fire, etc. But now, this goes at a very small rate. But what happens if you increase that rate just a tiny bit? Doesn't have to be at the same rate, does it? You increase it a little bit, it's going to produce a little more heat coming down into here. You produce heat that makes this area here more fluid. And now this can go faster, which produces more heat. And it goes faster and faster and faster and faster as it goes through here. This here is called runaway subduction because, according to the calculations, once it starts moving faster, nothing's going to stop it. It's going to run away. It's going to be like a conveyor belt underneath that continent. All right, now there's a couple of things that's going to happen when that happens too. You're going to find out that where this continental crust is coming across here, all right, this was heavy, dense material. The older the seafloor material is, the more dense it is. Now, this is less dense coming up. Fresh magma rising, producing a lot of what? Steam, vents, a lot of rain, moisture, etc. But as it's rising, okay, this is going to be now fresh volcanic material coming up in the center. That material is a lot lighter than the old continental or seafloor material. It's a lot lighter. That means the mantle can push up on it higher. It's going to go up higher. How much higher? Calculations show 7,000 feet higher than what it is now. Is that enough to drown you guys here? Drowns me in Colorado too, okay? That's enough water that's going to push that up to be one of the sources of the Noahic flood. All right, so we see that. And this is called the runaway subduction. If you go to discovercreation.org, look in the search function for runaway subduction. And I wrote an article in there, and it has that diagram, by the way, that you can look at real carefully and show other people as well. Okay? It's a great model originally by Dr. John Baumgartner. Okay? Okay, now, I see evidence when I look at geology for lots of time, not lots of time, but lots of water. Okay, this is a place in California. This is a hill that's 600 feet tall, and it's made up of water-worn boulders. Water-worn. They're rolled around like in a river, right? But look at the size of some of those. An earthquake cracked it open so we can see what it's made out of, but that rounded boulder right there is the size of a dump truck. That's a big one. Do you understand it's going to take a very high velocity, a deep current to move boulders that size and pile them up 600 feet tall? For sure. Okay, we're talking about a lot of water here. and great velocity. Look at these boulder layers here in another spot in California. You see they're boulder, rounded, but some of these boulders are the size of that Jeep. What does that tell you? Again, high velocity, deep currents. But there's one layer followed by another layer, followed by another one. This means they're pulsating currents. They're going fast and then they're slowing down. Going fast. Every time they're going fast, what are they only putting down? Bigger material. When they're going slow, they're putting down the finer material. Okay? That's how it works. Here's another boulder material. The black material here has rocks in it, the big boulders, but notice how it forces its way into the sandstone here. Look at that. It bends it down this way, bends it up that way. Do you realize that means this still had to be soft when that occurred? Otherwise, it wouldn't be there. Okay? How long does it take to make this solid sandstone? According to standard geology, when you look at the geologic column in this particular area, they say this whole ridge took about 100 million years to form. Do you know, I just read a paper 2 days ago, it only takes 35 years for this type of sandstone to turn into solid rock. It doesn't need those millions of years at all. It would have been solid rock in just, let's say, a few hundred years for sure. That means that 100 million years never existed. Okay? Even though that's what the geologists would say. All right? And I am a geologist. I used to believe all that stuff, okay? Until I did my own research. Okay, Mount St. Helens erupted in 1980. It was a gorgeous place to go have a vacation until the mountain took a bad habit. It began to smoke. It's not good when mountains smoke near you, okay? Just not good at all. And not only that, it not only was smoking, but the mountain was beginning to bulge all the way from 18 feet to 40 feet per day. What would happen if you lived near a mountain and it was bulging toward you? What are you going to do? Run! Get out of there, right? That's what you're going to do. But anyhow, yeah, May 18th, 1980, all of a sudden, yes, it bulged, but it caused a great big landslide that took off 1/3 of the mountain. Then the mountain exploded straight up, okay? First of all, out the side, then straight up. What we ended up doing was, here's where the landslide was, but look at all this different material here that was deposited below. We look at it, that's all new, fresh deposits. And look at this great big canyon here. It goes for 8 miles back here. How long does it take to make a canyon? It's not on the map prior to 1980. Okay, so it doesn't take long. And a lot of these layers are made up of very fine material. And they're called pyroclastic flow. You know, when you have volcanic ash being blown out, everything goes up in the air like that, right? What goes up has to come down. And it comes down like this. Whoosh, whoo, whoo. And it makes a whole series of layers very rapidly. Doesn't take long to make layers, by the way. But they said, well, look at Badlands. You know, it takes millions of years to develop a Badland topography. So we got millions of years there. Well, Ranger, didn't we see the same kind of formation occur at Mount St. Helens, and it was in one day? He said, well, Mount St. Helens was a special case. Well, maybe this is the best special case too. And yes, we can get Badland topography. There were secondary steam blasts at Mount St. Helens that produced Badland topography, steam pits in one afternoon. That's all it took. Okay? Special case? Yep. But who knows how many other special cases around. Look at that big canyon right there. It goes for 8 miles back there. Not on the map prior to 1980. How long did it take to carve that big canyon? 1 day. That's all. Even part of a day is all it took. 8 miles back there. You can just see that back there. All right, here's what National Geographic said. You would expect a hard rock, this is soft rock, a hard rock canyon to be thousands, even hundreds of thousands of years old, says Peter Frenzen, monument scientist. But this in less than a decade, less than 10 years. Guess what? The bulk of it, 1 day. Okay? It doesn't take long. And that was just a little bit of water from the glaciers on Mount St. Helens melting pretty quickly. What kind of water, what kind of erosion are you going to have with the waters of Noah's flood? The whole world's going to be covered by water, right? There's going to be tsunamis going back and forth. There's nothing going to stop them. So you're going to get huge erosion and lots of mud deposition. Okay? Now, later the mud turns into rock, right? Doesn't take much longer. It turns into rock. When you see petrified mud, think flood. That's a principle of geology. You're going to be right most all the time, okay? But again, with the huge amount of water going on in Noah's flood, you're going to have major catastrophic, you might say, repositioning all of those rocks that were there before, okay? All of the mud, all of the sand, etc. When I look at Bryce Canyon National Park, I see a lot of petrified mud. Think flood, okay? I go to the Colorado National Monument. I live pretty close to this. And when I look at that, I see petrified sand mud that looks like it was deposited underwater, not by wind. And when I look at that, I see petrified sand mud, I think flood, okay? That's me. But I think it fits pretty well too. But you know, you'll hear the rangers say, well, look at the canyons. It takes millions of years to carve these big canyons. Not so, it's Mount St. Helens, right? And then when you go right around the corner to where they say this took 1 million years to carve that canyon, you see a canyon and then a canyon on the inner part of it, don't you? This is a canyon within a canyon. That means there was a lot more water going through there at one time, and then the water channelized and gave you the inner gorge right straight through there, okay? That's what we're seeing right there. By the way, I live right down in here, okay? Grand Junction, Colorado. And we have some gorgeous scenery there. All right, let's go to Eastern Washington. Well, there's some people doing a lot of research in Eastern Washington, all the way down along the Columbia Gorge, all the way to the Pacific Ocean. They were starting to notice big boulders around each bend, big boulders. And they said, how did this happen? Some people said, oh, it must have been glaciation. But then there was J. Harlan Bretz who said, no, there's a major water flow through here at one time. And he did research. He spent a lifetime doing it. And he said, there is some catastrophic water going. Everybody ignored him. Why? Because it sounded like Noah's flood. They ignored him. And so basically he kept hammering away on it. And then finally there was another geologist upstream working way hundreds of miles away. And he started noticing shorelines of an ancient lake way above the city of Missoula, Montana. It would have drowned, that lake would have drowned Missoula to a depth of over 900 feet, okay? And then they started doing the research and they realized, wait a minute, there's probably an ice dam right after this And during this glacial age, that dam, that branch of the Columbia River, dammed it up and made this huge lake back upstream that contained 500 cubic miles. The lake itself would have been 3 times the size of Rhode Island. Okay, this is a big lake, isn't it? Um, Water all the way up this direction too. Well, the depth of the water at the dam would have been 2,000 feet deep. Do you realize, any engineers in here, you think ice is a good thing to dam up a lake that size? Nope. Finally, it breaks through. And when it breaks through, it cuts through here, takes out another lake called Lake Columbia and another one, and all that water goes across eastern Washington. And that area of eastern Washington now is called the Channeled Scablands. This is standard geology, realizes it was a catastrophic flood that just carved the entire countryside, leaving a spot of canyons 100 miles by 200 miles. That's pretty big, isn't it? All right, so that's what they now realize. Here would be Missoula, Montana. There's the shorelines, and look at that amount of water. Get a lot of water, you get rapid canyons, can't you? And a whole network of them. And so that water was released, and we can't even draw a good picture of it. Our calculations show, and when I was there, we were taking some GPS readings and some elevations. I was finding river cobble from the flood 700 feet above the current level of that lake, of the rim there. That means the water depth was at least 700 feet higher than this rim. Okay, when it was all said and done, the water would have been way past here. There'd been a whole series of waterfalls all the way up through eastern Washington. It is 22 miles from here to Soap City, Washington. The canyon that I'm talking about is 22 miles long, 6 miles wide, 900 feet deep. How long did it take? 1 day, maybe 2. Okay? That's standard geology today. Okay? Doesn't take long when you have enough water. Okay, let's go to another channel of the same flood. This particular channel, it shows it's 180 feet right here. Close to 60 meters. Okay? That's a lot of water going through here. But look at the plunge pool. Whew, that's a pretty good sized plunge pool for that amount of water. That tells you there was a lot more water at one time. The clue, another one, are the rounded hills and the gravel deposits below it. That means the water was even above the horizon, going miles and miles in both directions. That's what happens when an inland sea or a huge lake suddenly catastrophically drains, okay? And you get Palouse Falls here. That's called Palouse Falls. And when you look downstream, you have a cliff. It's 1,300 feet from here down to the bottom. And when this goes 6 miles all the way down to the Snake River Canyon, okay? 1 day. That's all it took for that one, too. Look downstream. You see these boulder fields, okay? Keep that word in mind, boulders, okay? If you're with me on a field trip and we're driving along, I'm going to say, boulders. That's a clue, isn't there? You see great big water-worn boulders? You dig down this way in Quincy Basin, you will encounter these big boulders for a depth of 300 feet minimum, okay? That's how much rock was taken out of this area and deposited downstream. All right. Oh, near Escalante, Utah. This is a long ways away. It's a different area, a different flood. What would you think I was going to say when I was driving students by that? Boulders. We'd stop and look at them, right? And they're good sized boulders. But then we find out there's a canyon on this side, a canyon on that side. The boulders are all on top, indicating that the water channel carved out both channels, leaving some of the boulders on top of the canyon. That's what it is. Oh no, boulders, right? More boulders. Look at that. It's kind of like a potato field here in Idaho. And look at the size of those boulders, the size of that Suburban. And our friend Diane Galbraith, okay, right here. There she is along one of them, but some of them are bigger than her Suburban. And Dan, where are those boulders? Well, how did you get them? Okay, there's a clue. Look upstream. Look upstream. What do you see here? Shorelines of an ancient lake, okay? Those shorelines would have been about 1,000 feet higher than the present level of the Great Salt Lake City, Utah, okay? All right, 1,000 feet higher. That means 1/3 of the state of Utah would have been one huge lake, okay? One huge lake, 1/3 the state of Utah. Now, all of a sudden, this lake catastrophically drains that way, goes up this way, goes that way. And then what it does is, in a great big water flow, huge amount of erosion, you have Snake River Canyon formed. According to the signpost, this is current geology, right? According to current geology, according to the signpost too, this canyon was not here 30 days before this great big lake in Utah broke apart. That big lake is called Lake Bonneville, okay? All right, so we have two big lakes collapsing in northern Utah as well as into Montana. So you've got those big lakes. And where are those boulders, by the way? The size of the Suburban. They're on top of the canyon. That means the water depth is at least a couple hundred feet above the horizon. Okay? Lots of water. Going to get a lot of erosion in a short period of time. Dr. Dury is a geomorphologist. He's been going around the world looking at river channels. And his conclusion, 95% of the world's rivers and streams cannot be explained by today's current flows. They all had a much greater amount of water in them. Where would you get that water from? How about the aftermath of Noah's flood? That would do it, wouldn't it? Okay. All right, you go to Siberia, you find something like Lake Missoula and Bonneville, another thing, but this is 10 times bigger. That's a lot of water. 10 times bigger. Siberia. Go to Wave Rock in Australia. This goes for 7 miles, bone dry today, but you can just imagine the amount of water going down through there. Again, evidence of a lot more water on the face of the earth. You know, time is not the hero of the plot. It's the conditions, isn't it? If you get a lot of water, you can get big canyons formed, right? You can get a lot of layers being put down real quickly too. You know, Charles Darwin was on the ship called the Beagle. They sailed along South America, and he noticed a lot of volcanic layers. He said, oh, it must have taken eons of time. We call that millions of years today. Eons of time. Well, guess what? No, it didn't. All right? In fact, when we saw Mount St. Helens erupt, what did we see? One day. Same type of layers. Didn't take long. And then you've got river carving. They took a boat up this particular river, And he said, oh, it must have taken eons of time to carve this river, to carve through this bluff. You know, he missed a few things. Oh, he did. In fact, he missed boulders the size of an automobile up here. He missed boulders down through here along the channel, like those guys right there. He never noticed it. Okay, but those would be great clues to look upriver for the collapsed lake. And they now believe there was a lake that had collapsed way upstream, forming this particular river valley. Okay? All right. Now, when I look at layers like this, I think of flood. When I see erosion like that, I think flood as well. Now, here is the Canyonlands overview. From where I am standing, taking this picture, look across there, 18 miles. You know what you're seeing? Huge, huge water channels through here. Lots of erosion, short period of time. That's what I see. All right, I look at the Grand Canyon. I see, where did the rock go? Remember those big boulders of the size of a dump truck? They're downriver from the Grand Canyon. I see evidence of a huge water flow that moved those boulders on down, okay? The standard interpretation, it took millions of years of gradual erosion. The canyon should be choked with rocks. What do I see? Evidence of a huge collapse of a lake or two that actually catastrophically drained right through here. Where are those boulders, by the way? Right there at the tip of that arrow. Smoking gun, isn't it? Yeah. And can you imagine the amount of water contained in this particular assemblage of lakes? All of a sudden, catastrophically draining. Will it take weeks? Or was it going to take only days to carve a big canyon like that? Certainly doesn't take millions of years, does it? No, not when you have that. All right, here's another canyon. This is about an hour and a half from my house. It's called the Black Canyon of the Gunnison River. Now, did this little Gunnison River carve this big canyon? Probably not. Here's another way to get a canyon. Not just a lot of water. Let's suppose you have a big earthquake. Ground is shaking. Crack. How long did it take to make that big canyon? Just like that, right? Doesn't take millions of years. And this is what I would call a tear fault, okay? And evidence seems to support that as well. I was looking and enjoying the Sierra Nevada mountains, but then I started noticing way off in the distance, this looks like a water channel through here. And so I decided, Mary Jo and I, climb down this cliff, okay? We climbed down into the valley, and yeah, sure enough, first thing we noticed, water down there. Great, that's not much water though. But then we started noticing the basalt. Notice how it is sculpted by a huge amount of water. Okay, again, another big flow. So think about it. When you get a lake breaking, a big lake, at first the water is crystal clear, right? Then all of a sudden it picks up a lot of sand. It'll pick up boulders. Pretty soon you have a cement slurry going downstream at 60 to 70 miles per hour. We can't outrun it, okay? That's what happens. The cement slurry has to stop someplace. Well, here's one place it stopped in Death Valley. This is a boulder dump, okay? One big boulder dump right here. But as it went through, it carved a canyon on the way through. And look at that. You can see how the cement coated the side of the canyon, didn't it? This is cement coat, okay? That's why they call it Mosaic Canyon. Where's that dump? Right down through here, all the way through here. All of the sides is coated with cement, okay? That's what happens. You get that, it's clear water, very quickly turns into a cement flow. All right, now, well, I see evidence of the flood through there. And I see evidence of the flood putting down those layers, but the standard geologist would say, we know how old those layers are. It took millions of years. Oh, do you really? Sir, how do you know? how old those layers are in the Grand Canyon. Talk to the ranger that way, but do it nicely when you do it. Okay? And he says, well, all of the layers have been dated in the canyon. And those methods are very accurate. Sir, I'm a geologist too. Are you aware that there isn't a single one of these layers in this Grand Canyon that you can date by these dating methods, because these layers, all the way from here down to the inner gorge of the canyon, not one of them can you date by radioactive decay dating methods, because these rocks, these layers contain the wrong kind of rocks. He was the geologist, said, you're right, I forgot about that. Okay? And so then I showed him some things about that. I said, you know, you always say they're so accurate, but you're always using them to date a rock of unknown age, right? How do you know if you're right or wrong? The only way to tell is to date a rock of known age, okay? And let's find out how good your dating method stacks up. A recent volcanic lava flow, basically in a dome built up within Mount St. Helens. That was about 30 years from the time of the original eruption. So they decided to date that volcanic lava dome. They knew it formed 30 years ago before their date. The dates they got, minimum 340,000 years old, up to 2.8 million years. Something's wrong. Same thing happened in New Zealand too. And then even in the Hawaii, they've had recent volcanic lava flows dated a minimum of 3 million up to 1 billion years. Something's haywire here. It shouldn't be that way. Then you look in the Grand Canyon, and I pointed this out to the ranger. I said there was Vulcan's throne. The lava from this volcano actually flowed down into the canyon at one time. Now, if you were to date this lava flow, you should get a very recent age, right? He said, yep, that's exactly the way it is. I said, oh, no, it isn't. Every time they've dated this recent volcanic lava flow, they've ended up with dates at least as old and up to twice as old as the rock layers underneath the entire canyon. He said, no way, your data's got to be wrong. And I said, well, here it is. Take a look at it yourself and do your own research, and I'll be back. Excuse me. The next year I was back. I saw the same ranger, same spot in the canyon, giving the same ranger talk. So I asked him the same questions. He said, oh, you again. Then he said, I found out you're 100% right. Well, good. But there's a good answer to the problem you brought up. I said, what is that? He said, well, these methods have been shown to be not accurate on recent events, indicating they're okay. Just happened. Okay, I guess I know. I'm all dry. Do you mind get me a little bit of water, Jonathan? Throw this at Jonathan, okay? Thanks. All right, thanks. Oh, wait a minute. I have some. Don't worry about it. I have a little bit. It's sitting right in front of me. I worry about me too. Yeah. Okay, what he said is rocks of unknown age can be dated accurately. I said, how do you know that? If rocks of known age don't give a good result, how do you rely on them to give you accurate results on rocks of unknown age? He had no answer for that whatsoever. Okay? None. Okay, when I look at those layers, I see evidence of the flood. And I see evidence of not there at the canyon specifically on these things, but from elsewhere, I see evidence of catastrophic burial. That fits with the flood. Whole clams. A clam normally opens when it dies. These are all whole. They didn't have a chance to dig their way out. Okay? And then we go into the Grand Canyon. What do you see? Fossil nautiloids, millions of them, all pointed to the same direction, indicating water flow, and they were buried that way, okay? And a squid-like creature were in those particular nautiloids, and you can find it way down deep in the Grand Canyon. Okay, a great book for you to get, a guidebook to the Grand Canyon from a creationist viewpoint. And I will have to say, not because I'm biased, I probably am, it's probably the best guidebook I've seen of the Grand Canyon, okay? It's really good. You go to the Kemmerer, Wyoming, you see fossilized fish, 360 of them right here. Not a fin in place, or out of place, not a fin out of place. They're rapidly buried. It's little fish like that with not a fin out of place, or even bigger fish, a palm frond that's 10 feet long, no deterioration, fish along with it, all of it got trapped. How fast is the burial? Rapid. Otherwise, it would have decayed. How rapid? That guy is eating his lunch when both of them got trapped. You understand? Sudden destruction was upon them. That's something right out of 2 Peter in the Bible, isn't it? Sudden destruction. You go to see a mass burial, Dinosaur National Park. All kinds of dinosaurs ripped apart. Well, some of them weighed 70 tons. So we're talking about a massive flow that's going to rip apart a dinosaur like that, right? That's what we're looking at. So when I look at these layers, I hate to say it, but I get hungry. Yeah, I see all these layers of rock, and I think of pancake layers, blueberries and chocolate chips in it. That's what I'm thinking. And then I see the butter on top, the syrup dripping off of it. And I say, I get hungry. But what do you do when your pancake layer has one petrified tree going through a good share of it? Like that. What do? You'd realize, yeah, that pancake had to have been put down pretty quickly, right? Otherwise, that tree would have rotted. But then you notice one other thing. What if it doesn't have any roots? You know, trees don't do well without roots. So it was ripped up, roots broken, and then buried. Well, that's what you would expect to see. And if what I'm saying is correct. Well, here's one of them right here. It's found right here in the eastern United States. You see one of these trees going through many pancake layers. We go around the corner. What do you see? Here's one wonderful one right here. Here's another one. Another one over here. National Geographic actually had that picture, or one like it, in it as well. Roots broken off. No deterioration. Those pancakes are not 100 million years old. Okay? These were put down extremely rapidly. All right. It's not just in eastern United States you find it. You find it clear up in Canada. You find it in Nova Scotia. You find it over here in Australia and New Zealand and Russia and Germany for sure. Other places probably as well. But that's just a few places, okay? What does that indicate? A lot of water burying things pretty rapidly, ripping things up, redepositing them. Okay, now what would you think if you have a stack of pancakes, but your bottom one somehow fluidized and poked its way through all the rest of the pancakes? You'd say you didn't cook the pancake long enough, right? All right, that's what you would say. But we see that at Kodachrome Basin in Utah. In fact, you see the bottom pancake layer. This is their own schematic going through all these 30 million years of pancake layers, poking out through the butter. Again, quickly, this had to have formed. Okay? Otherwise, it would have been solid rock, wouldn't it? Yeah, it doesn't take long for sandstone to turn to rock. Okay, let's look at a couple of them. Here's one right here. There's my old van right there. And now, wait a minute, what's this one in the distance? That's another one of those pipes coming up through the top of all those. But it emanates from below. Here's another one. It looks like toothpaste being squeezed out of the tube, doesn't it? And again, emanates from below, goes through all of those layers. That tells me those layers were above that went through were not 30 million years in the making. We're talking about something catastrophic, pushing it down this way, hydraulic activity, boom, things coming up. In Kodachrome Basin in Utah, there are 165 of these formations, okay? 165 of them, all indicating what? Catastrophic burial, catastrophic activity during the flood, okay? Anyhow, all right, now, I'm summing it up right now, okay? This is very important material, what you're going to be seeing. All right, you go worldwide and you see a boundary between unlayered material frequently, sometimes layered, maybe they're tilted, and then stratified layer on top. You say, so? Well, this thing is worldwide here. And that would be the worldwide place where what? Got planed off during the catastrophic flood. And then the sandstone layers, etc., were put on top of it. This is the sandstone layer at the Grand Canyon, put right on top of unstratified layers. But look at this. This is sandstone. I think it's probably water deposited. What do you think? Because wind can't deposit a block of rock like that, can it? Okay, we're talking about water deposition here and carrying along, and all of a sudden drops those big rocks. This is a catastrophic carving and putting down rocks in between. Now, that particular layer that you see at the Grand Canyon doesn't stop there. You see it all over North America. Everything that's white, okay? It goes all the way down into Mexico, all the way to the eastern seaboard. It's actually been basically eroded through here. Now you have what? All the way north of Greenland, the same pancake. Big layers or big pancakes tells you what? Broad distribution. Not a local flood. It's some kind of a global event, okay? And we also see the same thing with limestones too. It's pretty obvious once you look at the geologic record here. Here's a limestone layer. It's actually layered like this. It's standing on end. The Pikes Peak came up, took the flat layers and pushed it up like this. Whew. Okay? All right. That layer flattens out just a few miles further east on the one side of Colorado Springs, Colorado, goes all the way across Kansas, all the way to the Atlantic Ocean. Okay, that's a big pancake, isn't it? But it doesn't stop there. You pick it up again. You know where you see it next? The other side of the ocean. You see it, it's called the White Cliffs of Dover, okay? Now they found it in Israel and in Spain, and they're thinking they're also finding it in Australia and New Zealand. Same pancake. What is this telling us? Worldwide flood, nothing slow and gradual here at all, okay? A lot of water and a little bit of time, okay? And so that's what we see. These are monster pancakes going all over various parts of the world. So the most documented biblical event is supported by what? Archaeological evidence, cultural evidence, right? Biblical evidence, all right? And much geologic evidence all around the world. And so what would be my conclusion as a geologist? Noah's flood, is it fiction or is it reality? I say reality. And as a geologist, looking at the layers and thinking about what the Bible says, the Bible says there was a flood. What are we seeing? Evidence all over. It makes me take seriously not only those chapters of the Bible talking about the flood, but also all the other writers that talk about the reality of that flood and Jesus accepting it as well. God says there's going to be another judgment coming. This was a major one, wasn't it? There's going to be another one too. And because as a geologist, I see that as a reality, makes me take the rest of the biblical record seriously. And I better live my life accordingly. Okay? So that's what I see. It talks about a big flood in the past. You know what the new ark is today? Lord Jesus Christ dying on a cross, isn't it? If people laugh, there were only 8 people that went on board that boat. Only 8. Okay? It was a monster boat. There's room at the foot of the cross for a lot of people. But I hope there's a lot more than 8 to go. Okay? I really do. And that makes me think about it a little bit more. Yeah, if this is true, that ark is true, what Jesus did on the cross, boy, I better believe it. And I better live my life according to that. I'm going to turn this back over to Jonathan here real quickly. But what I want you to make sure you do is discover creation, but worship the God of creation. Okay?
Right.
Jonathan.
I want to welcome Mary Jo up here now.
Yeah, better do that.
I won't call her better half. We'll say.
Well, I would. No,
We're whole
it's not. Yeah, we're both whole
I
people.
would just say she's more whole than you.
Oh,
Okay.
well, she's. I don't know. She's broken.
Yeah, well, it's healing.
She's got a broken wrist.
No, she doesn't.
She tried to. No, it's healed now, but she has to still wear a brace a little bit. Yeah, she tried to be super lady, and we had friend's house. She decided to fly off of their high porch, and good thing her wrist took the brunt of it. Her wrist took the brunt of it, unfortunately, and her glasses that cut her here. Otherwise, her head would have been hitting the pavement or the concrete, and that would not have been so good. But anyhow,
I did find out I can't fly.
she can't fly.
I'm not a bird.
Oh,
Someday-
rats.
Someday we'll fly,
It took
won't
you
we?
a few years to figure it out.
Yeah, it took a while. I'm a slow learner that way, Jonathan.
Well,
Gotta keep.
anyway, so we're gonna have some
That's
Q&A
right.
time here, and so if you guys got some questions you'd like to ask David, Mary Jo,
If you have a phone, give it to her to take a picture up against this.
I want to encourage you to stop by the book
Yeah, you
table
give it
before
to
you leave here tonight, and
We'll
there's
do
some
it later.
Bibles and other literature there.
Well, you can give it
Nice
to her.
to see you. I see this young lady every day on campus. She works here, so.
That helps.
I got to talk to Matthew there and learn a little bit about you guys. It's really unique, so.
Uh-oh.
But
Was it good or bad?
anyways, so we're gonna have just a Q&A time here. So if you guys got some questions, feel free to ask that. And those of
Did you
you
get
who are
a picture
online, if you have some
closer
questions,
of Mary Jo and I
to,
up against the
ask
screen?
them as well, because we can see
picture.
your questions online. All right, well, I'm gonna just turn it over to these guys.
Okay.
And go on ahead and raise your hand if you got a question.
Yeah, before they ask a question, I just want to encourage you, if you did not see the program we did on Sunday morning, it's on the Maranatha YouTube site.
Yeah.
Highly recommend it.
Yeah.
We talked about 2 Peter chapter 3 and how the scoffers and mockers in the last days were coming and saying, you know, Jesus is never coming back. He said he's coming back. Where is he? Peter takes the people right back to the reality of creation and the flood at that point.
It's true.
And so I would encourage, go ahead and go online and take a look at that
Uh-huh.
if you weren't there.
Yeah. Okay.
Questions?
Who's going to go first? Oh, okay. Who's going to go second?
So,
It's always hard to go first. Who's going to go second?
all right. was a worldwide flood and the ark, you know, is it feasible to fit all the animals, two of each, as well as there were other amounts of animals that went on there as well, but is it feasible to fit them all on the ark? Maybe elaborate on that.
Yes.
Interesting, yes. In fact, there's a whole book that's called Noah's Ark, a feasibility study. And it shows in that book, many of the questions that people have used as reasons not to believe in the ark. Like, maybe there wasn't enough room for the animals, or maybe how could Noah get all the food on there? What about air? What about water? What about removing waste products and so on? Lots and lots of questions. And the author of that book did lots of in-depth research on known animal husbandry and physics and stuff.
Physics and animal distribution.
It's on our website if you're interested in that. Noah's Ark feasibility study. Yes, there was plenty of room on board the ark for all the animals that had to be there. And remember, there didn't have to be fish or any of the marine creatures. And only two of every kind, except 7 of the clean kinds. What would in the Levitical law would be called the clean animals. Those were the ones that were available for food and sacrifice, and so there were 7 pairs of those on the ark. And when you start to think about it, it says 2 of every kind. It didn't say 2 of every species. The species is something that we humans have come up with in our attempt to categorize and classify all the living things on the earth today. And it's really, all of the classification schemes are man-made, you know? And so we have to take that a little bit, you know, and what creation scientists are doing. There are scientists that are creationists who are looking at a different kind of classification scheme. They're calling it bara-minology. Bara meaning created, min meaning kind. And so bara-min is the study of the created kinds.
Yeah.
And they're looking at how could we come up with a different classification scheme that would be consistent with what the scripture says. We think in a lot of the animal groups that classification scheme might be maybe more at the family level, like the dog family. And in plants, it seems to be a little different. But then the plants could have survived, many of them could have survived outside anyway. In this flood, probably there were great mats of floating vegetation. And so, you know, those kinds of things that the plants could survive, and the seeds and so on. Even today, if you wash up a coconut, can go all the way across the world and reseed a coconut tree on an island far away if there's been a tsunami or something and wiped out the vegetation.
They actually found a fish that were deep sea type fish washed up way inland from the tsunami in Indonesia. Okay, they even found that.
And
it's amazing what you can do with some of those currents.
Did you talk about the tsunamis? Flood?
I just mentioned about tsunami.
Is that one of the current research ideas that has been currently being researched at the Institute for Creation Research and in some other places is the idea, it's called runaway subduction.
Oh, I did talk about that.
But what it does is in the process, would create gigantic tsunamis that would come up, bury one level, and then it would come back out and go back further onto the land and further onto the land and so on. So you could see varying patterns then of distribution of the fossils within the fossil record.
Okay, another question back there. Really loud, please.
Yeah. Do you think the tectonic plates were separated back then, or the flood is the result of that?
He's asking what about the plate tectonics when it was separated?
When it would have been separated, according to Dr. John Baumgartner's model, that would actually have started during the tail end of the flood and continued afterwards. Okay, just to some extent. Today, it's still continuing. Okay, now some motion like that is very important. Okay, some seduction is important. And I believe that's part of God's creative design to begin with. Why? Otherwise, you get stagnant oceans. This keeps it fresh. Okay? Yeah. All right, I'll ask you a question. How do you explain an ice age? I know it's getting toward winter. It is Minnesota. You're going to be thinking about it.
Okay. Now you know the reality, the movie.
Oh, it's had to have happened that way. What did he say?
All the surface water lowered the temperature of the earth.
Mm-hmm.
How did that work? How many ice ages were there, by the way? I mean, secular science tells us there's many advances of ice, right? Many advances of ice over thousands and thousands of years. We think the conditions on the earth would have been just right to create one ice age after the flood with warm oceans. The oceans would have been warmer than they are today, which means there would have been more evaporation off the oceans. And as that evaporation moved across the continents, at one point it became cold enough, let's say in central Canada or something, where now instead of rain, it turns into ice and snow.
Lots of snow.
It starts to build up very, very rapidly, and the glacial advances are almost from a central point in the northern continent, spreading out, not starting at the polar regions and coming on down like we might think. But as that would happen, eventually you'll reach a point of equilibrium where the waters in the oceans cool down enough and it slows this whole process down a bit. Only one major advance. And you can see, I mean, here in Minnesota, you can see evidence of the advance of ice ages. Now there could be some, melting back a little bit and moving forward a little bit more in seasonal patterns and so on, but not the major advances that we see in secular science.
The key to what she is saying is very warm oceans after the flood, because we cannot have an ice age today. I don't care how cold we think it is here, okay? We can't have an ice age right now because there's not enough differential between land mass and water temperatures right now. So you need to heat up that ocean a lot, which you would end up doing at the flood, because what we see in flood layers and we see underwater deposited volcanics, a lot of it. And in fact, you've got in the western United States, you have 30,000 square miles of basalt. It's called the Columbia basalts. But in India, we have 100,000 square miles on the Deccan Plateau. Again, underwater volcanism that's going on here. That's going to heat up that ocean quite a bit. Now you have the friction of things banging against each other, right? You've got the undersea volcanism with the big mid-Atlantic spreading ridges too, underwater. Fountains of the Great Deep. You get the condensation of rain. Again, you're producing a lot of heat into the oceans. So when you do that, what happens is the ocean becomes quite a bit warmer. So you have a worldwide El Nino effect as well. And all those hot air masses coming across gives you this huge buildup of the snow that we're talking here. Okay? By the way, another supporting evidence of what you just said happens to be that the fact that the north shore of Alaska was never glaciated. I learned that in geology years ago. It wasn't glaciated. So the glacier started more central and moved radially out. Okay? That's what we see.
Why would that be? Why do you think the North Shore of Alaska wouldn't have been glaciated?
What?
Yeah,
Take a
warm.
guess. It's okay.
You got warm ocean water, right? And
Look at all the water you have up there.
there is along the North Shore of Alaska. It's plenty of water that at one point was warmer.
Yeah.
And it's also interesting if you have all this water now that is piling up and making the glaciers. Remember, God told the people after the flood, be fruitful and multiply and fill the earth, right? How could they do that if all the continents were separated? It'd be very difficult. Now we can do it with boats and stuff, right? And we think they did at certain points. But in the beginning, in the early days after the flood, and as a lot of water contained in those glaciers would have lowered sea levels, which would have made a land bridge from North America to Siberia over what we call the Bering Strait.
It's
today.
not going to be a little narrow spot. It's going to be a big, broad, wide spot.
And so you could have had migration of people and of animals coming across that area of the Bering Strait, walking on dry land, because the edges of the continents, again, would have a more mild climate than the interior, which could be why we see similar people groups, similar animals from Siberia, from Mongolia.
Okay.
We went to a natural history museum in Mongolia. It was built when the communists were there, when Russia was in control of Mongolia, and they had this museum built. And the Mongolian people said that their ancestry had come from an area around Turkey, but that they weren't Turkish. Now, what does that spark in your mind? Where did the ark land?
In that region
In the
of
mountains of Ararat, which is in eastern Turkey. Okay, so if the ancestors of the Mongolian people migrated from that area all the way up into Mongolia, into Korea, some of them into China, and then some of them came across the Bering Strait, became some of what we know as the Eskimo groupings today,
Yep.
and even down into the Americas and the Navajos and so on. It's interesting how much similarity there is in the cultures between the Navajos, the Eskimos, and the Mongolian people. I have a picture. When we went to Mongolia, I took a picture of the little kids. And boy, they were so cute. But what impacted me was when I looked at them, they looked just like the little Eskimo kids or like the little Navajo kids.
And like the Navajo
So
kids,
much
which is way
similarity.
southwest United States. Okay.
And I think they are related. I would love to see some genetic studies done on that. And by the way, this is a free little bunny trail. There are creationists who are doing genetic studies now on North American Indians, and they're finding out that the secular theories of how the Native American Indians got here may not be so correct. And what they're doing is they're combining genetic studies with cultural history studies by these Indian people. And they're looking at the two together, and they're finding some very interesting findings. If you're interested in that, it's a book by Nathaniel Jensen. It's called Traced, and it's fascinating because he kind of weaves a story in there too. He was very fascinated in the Native American people, but he's also a geneticist, very well trained geneticist, and he's got some other more technical books. If you're a biologist or a geneticist and you want the technical stuff, he's got more technical stuff too. But this book Traced it's got genetics in it, but it's more on a popular, I don't know if I can say popular
You wouldn't
level.
call it a popular level.
But at least it's more approachable than some of his other books.
Yeah. Of course, I'm into geology, you know.
Elaborate more on how we have, because obviously it was, you believe that it was Noah and his wife, and then his 3 sons
Yep.
with their wives, so 8.
Mm-hmm.
So could you elaborate more on, I mean, I'm obviously white, and Pastor George here is black.
Yeah.
Uh-huh.
And I don't know, and then Jacob over here is more of a brown complexion.
Yeah.
You could elaborate, how did we end up like this with Noah and
She's the
his wife?
biologist.
Yeah. And you can explain that very easily based on simple genetics. We showed the other night how if you draw a Punnett square and it shows that with 2 parents of medium skin color, you could get all the way from lightest light to darkest dark in 1 generation. Now, of course, there's some parameters that are in that if that's going to happen. But yeah, maybe you can find that slide, Dave.
Oh, I'll find it real quickly.
Very interesting. You can sketch it out in what's called a Punnett square. And this is, yeah, you know. Some of you have seen Punnett squares and you like them and others hate them, right? I think it's a cool way to illustrate the potential possibilities. And when we bring that Punnett square up, you're going to be able to see. We got Pastor George George, right? We got you in one of the spots up here. Go another one.
All right. Right
There
there.
you go. Okay, starting with the maximum variation in the parents. That's called a heterozygous condition, for those of you that know biology. But if you start with that, with 2 parents of medium skin color, this combination would give you medium skin color, like right here, okay? Those were kind of medium color, like your friend over there, okay?
Uh-huh.
You could get that medium, but you could get all the way from darkest dark to lightest light. 1 generation.
Yeah.
And we showed the other night, these are 2 parents with 1 set of twins, biological twins.
And here are the girls when they grew up a little bit, right here.
I like to look at that and go, where's there room for racism in that kind of a situation?
Yeah.
There isn't, is it? Now, how would we get those racial characteristics cemented in a grouping, right? Because normally we don't see this setting, do we? Normally that isn't what we see happening. But
It can happen.
go back again. If we take these 2, if we take 2 parents with that kind of a combination of genes, all of their children are going to be very dark. If we take this one, all the children will be very light. More realistically, it's probably somewhere in between. I don't think a lot of us are pure 100% dark or 100% light. So I think there's some other variations. We also know there are some other factors that enter into skin color. So this is very, very simplified, but what it does do is to show you with just 1 generation, you can get all the variation of skin colors, lightest light to darkest dark.
What does that say, though, about Noah and his wife and his 3 sons? Because would they have been of a darker complexion, probably?
We don't know what
I doubt if they're white.
We don't know what their genetics were like. Think about it.
Give me your theory.
Well, I would say they were probably, it could have been any of these. It could have been here, Noah could have been here and his wife here. And within 1 generation, they would all be right here.
I thought you said you can't go from light to dark.
Oh, well,
No, you
she's
can.
going
If you
light
take-
and dark, mixing them.
If you have Noah's
Okay.
Noah's wife extremely light and Noah being extremely dark, the next generation's all going to be in between. They're going to be like this. And it comes because they would have the dominant, so the capital letter representing the dominant gene, the little letter representing the recessive gene. And so down here you've got all recessive, and here you've got all dominants. Well, in their children, you end up with a dominant and recessive and a dominant and recessive because you're just taking them down here.
I think what he was having an issue with is you said something about, all these kids are going to be marked. They're not going to be able to have a white child.
No, like this.
But that's if they both
Yeah,
parents
two
have
parents.
that particular genetic combination. Then they can't produce
So
that
we don't
all-white
know
kids.
what I would assume, and it's an assumption, but I'm assuming because God wanted people to survive after the flood, and God loves the diversity. He made
Yeah.
it for I just think, because I think it's fascinating and wonderful. I'm so glad He made a diverse world for us to live in. It would be really boring if we were all the same color.
Yeah.
Very boring. I love going to different cultures. And with what we see, I think God probably gave really a lot of diversity even in Noah's family. We know nothing about the genetics of Noah's of his sons' wives. We don't know where. What cultures did they come from? What did they look like? But we know that with 8 individuals, it was enough to generate everything we see on the earth today.
Yeah.
We know nothing really about Adam and Eve. Adam and Eve could have both been medium skinned.
Medium.
Or
They had to have all of the genetic information that could produce those.
Or Adam could have been very dark and his wife Eve could have been very light, and we would have come out with the same combinations of potentials.
I really enjoy doing a study names, what they mean.
Yeah.
And Ham, from what I remember in my studying is he's like dark, or
Could have been.
yeah, and then Shem, is more of like olive color.
There you go.
And Jephthah was bright or fair. And so studying the 3 sons, you get the impression in the Hebrew when you study that Ham would have represented more of a darker complexion, and then Shem would have represented
Medium.
more of a brown.
Brown. Yeah, right.
And Jephthah would have been more of a white complexion if you went off the names. Okay, obviously that's not scientific,
Right.
but
Yeah.
I'm saying I think there's some hints there potentially.
Yeah.
The meaning of their name as to the complexion. potentially.
That could be. I haven't studied that.
Well,
It's
something I would-
interesting. That's
yeah.
interesting. And when you names in Hebrew, really, they had great amount of significance. And some of them, I mean, some of the names that are listed in some of the prophetic books, and you go, man, I'm glad that my parents didn't name me that name. And what was it, Methuselah? When I die, then comes judgment. That's what his name meant.
Oh boy.
And he died right before the flood. Now,
Year before the flood.
how would you
is
like
when he
to go
died.
your whole life with your name meaning when I die, then comes judgment? And so the names, they have significance. And the interesting thing to me is God, he orchestrates all of this stuff, and he brings it all to where it boggles my mind, the complexity.
Yeah, I would just kind of piggyback off the previous question. And then I have this one will be really quick, and then the other one will be a little more full. But I believe what you're talking about when I believe on Monday, you talked about how if you take that Punnett square and you have a bunch of different combinations, and you just have the 2 people or even a small number with similar combinations, you would very quickly cement those combinations of skin color into the population. I believe you're talking about the founder
Right there.
effect.
Yeah.
And I wanted to clarify that for the people that are listening, so if they want to go look it up online. But there's a lot of studies on this about different populations in Polynesia and various islands around the world. You have a tiny, small population of people, and you get certain traits which would normally be represented by a small number of people, become the dominant trait because they were the dominant trait among this tiny population.
Yeah.
That's
But-
one
Right.
way
And
to explain
that's
it.
right. That's called the founder effect.
Uh-huh.
And as far as the second question, the Fuller one.
Let me address something on that first, okay?
Okay.
When you look at it, when you look at the Tower of Babel, and then God separated the languages, it's rather interesting because God is the respecter of families. And it looks like when the people went off from the Tower of Babel, different family groups had gone out. If in a family group, you frequently have similar genetic combinations. Frequently, not always. In which case, now after a generation or two, that becomes, with the founder effect, cemented into the population. Okay? It doesn't take millions of years to do that, by the way, does it?
That's pretty much what you're saying, I think.
Yeah.
The other thing, just a side note here, is one of the guys that we work with down in Costa Rica. He's a professional translator, and he got very interested in creation stuff. And he was part of our training group down there.
Mhm.
He put together a talk on the origin of languages from a biblical perspective, as opposed to a secular perspective. It is very interesting to see, because none of the currently proposed views of the origin of languages from a secular viewpoint, they don't fit, they don't work, but the biblical perspective works. And it comes back to what Jonathan was saying, Shem, Ham, and Japheth, and we can see that in the genealogical records in Genesis. And you can see in place names, and you can see in people groups where they migrated to generally. That doesn't hold perfectly, but generally you see the differing areas.
Yeah, moving on to the Fuller question, I know this is something that we can observe today with blue islands. When they come up from the ocean, this also happens in Hawaii too with a lot of flows. It takes a shockingly small amount of time to go from solid rock to having a forest on top. So could you maybe explain more for everyone listening how easy it would be for a post-flood world, which I'm assuming would be pretty barren because it just got destroyed by multiple layers of catastrophic flood. How easy it would be to go from that to what we have now in maybe just a couple of generations.
Yeah, it wouldn't take long. Because it may be barren, but that soil tremendously rich in minerals and so on. And if you think of seeds and plants floating around in the water and coming to rest in various places, you could get quite a variety happening quickly. And yeah, you see that an idea in biology that we learn. It's called succession, where you get one ecological system replacing another one. So they will tell you, and you can observe if you go into places where there has been a lava flow, where you see lichen coming first. Well, they're a combination of mosses and algae and fungus, and you see them coming in, and they start to break down rock, and now you've got soil. And so you begin to have more differing kinds of plants building a new community there, and it doesn't take a long time. You could see it today, like you said, in the Hawaiian Islands or other places like that. Or you see it in places that have been devastated.
Yeah.
It's interesting, Mount St. Helens. We went to Mount St. Helens, and there's a lake there that they said was totally devastated. And they said it was like a sewer, It smelled bad. It was polluted. Within 3 years, natural biological processes had cleaned that lake to the point where it was crystal clear. So, it doesn't take a long time. You'll also see at Mount St. Helens some very interesting things. On the way up to Mount St. Helens, on one side of the road, the lumber company, Weyerhaeuser Lumber Company, after Mount St. Helens, they went in and they took out the logs that had been, fallen down and all that stuff. They used them for pulp, for wood, and for the particle board, and they They used them for paper and stuff, but they made use of them. They went in and got it. Then they replanted the area. And when they replanted that area, it was very fertile soil. The trees grew beautifully. On the other side of the road, it was left as wilderness. And I think it's a perfect example where God said to human beings to have dominion, which I don't mean in a bad way, but in a stewardship way, to take care of the earth. And where the humans went in and replanted those forests, the trees were a big, beautiful forest just 20 years later. On the other side, it still was recovering. It was recovering, but slower than with human care, coming in and taking care of the land. And today that's a big debate today is on the environmental protections and all those things. I love to come to farming country because where we're from in Colorado, I mean, it's just desolate in places, Dave likes it. It's rocks. Rocks and rocks and more rocks. It's very beautiful in a certain kind of way. But you come here where people are working the land and it's productive and it's growing things. As long as people have good stewardship practices, obviously, good conservation practices. It's kind of interesting in Grand Junction, the valley where we live. The interstate comes right into the town from east to west. And on the north side of the interstate, the hills are barren, totally barren. And they look like devastated, just devastation. Now the four-wheelers love it out there. They don't mind driving their four-wheelers out there. On the other side of the road, people have cultivated the land, they've irrigated the land, and the orchards and the vineyards are beautiful and very productive. And so, yes, things will come back, but they come back even quicker with human ingenuity and care and stewardship being applied. Any more questions?
All right, wonderful.
Well, it's good to be with you for sure. Thank you for your patience and thank you for being with us, and whether you're being online or here present tonight. So thank you. And Jonathan, thank you for hosting us and feeding us and all that kind of good stuff. We just appreciate that so much and appreciate the years worth of time that we could have together over. Well, I've been doing lectures here with you at the university now for 20 years. So praise the Lord for that.
We're getting a picture here.
Oh, good.
Oh, okay.
All right.
Okay.
Well, anyways,
So thank you. Good.
Dave and Mary Jo.
Thank you.
And anyways, I hope you all were encouraged and blessed and challenged in your beliefs as well about origins and how life began. And Lord willing, we'll have Dave and Mary Jo back again next year. And hopefully we won't have to compete with a Vikings game like we are tonight.
Oh.
So it started at 7:20, so I'm sure.
Boy.
But I have to say one thing is I think only Dave can make a presentation about rocks and, and sand and actually make it fun to listen to. I don't know who else could do that, But anyways, we're so thankful for you guys. And please feel free to hang out if you do have some questions you might have for Dave and Mary Jo yet. You can still ask them. And they don't have their list here, but on their website, discovercreation.org, is it?
Yeah, put the website up.
Yeah. They have lots of other materials and other websites you can go to pertaining to different things, but also all the lists of the books and materials that they have accumulated over the years that they feel are valuable in the study of creation. And the different sciences pertaining to that are available on their website. So anyways, thank you guys, and feel free to hang out and talk some more if you'd like. So
Okay.
You could get We publish a newsletter called Think and Believe. It comes out once every 2 months. That's a free publication if you want to get that.
Here's the
We're
QR code
also-
for that.
We're also doing online classes once a week. If you wanted to get involved with those, just get a hold of us at that.
It's not just us speaking on our online classes, but we have some other staff as well giving presentations. And so that's good.
Excellent. Well, thanks, guys.
Okay. Thank you.